Good day, everybody. Good day, viewers. My name is Dr. Bush, the chemistry instructor at the Peak Construct for Higher Learning, aka the Peak Tutors. Today's episode of Made Easy Clinic, we're going to be talking about the algebraic method of balancing chemical equations. Of course, when you are given certain equations to balance, you have different approaches towards balancing them. There are some equations that when given to you, just by investigating them, by just seeing them, you know how to go about it. Imagine I have H2 reacting with oxygen to give me H2O, and I was given this equation to balance. This is very simple. Just by investigating them, I know I have to put 2 here and I have to put 2 here, and then this equation is balanced. And you should note that when you balance chemical equations, you do not touch the subscript. If not, you are going to change the identity of the compound or the molecule or whatever it is that was given to you. So you don't tamper with what? With the subscript at all. You only deal with what? The coefficients. And the number of moles of each element on the reactant side must be equal to the what? The number of moles of those same elements on the what? On the product side. You should note that. So note, you do not tamper with what? With the subscript at all. So equations like this, when given to you, you can balance them just by what? By investigation. How about when you are given some kind of equations that are cumbersome, complex, and then you can't attack them just by what? By investigating them. Say I have an equation given as this. Excuse me. Okay. I have A moles of K4 FeCN6 reacting with B moles of H2SO4 reacting with C moles of H2O, giving me the product D moles of K2SO4 plus E moles of FeSO4 plus F moles of NH42SO4 plus G moles of CO. Wow. You will agree with me that this equation is very, very complex. So how do we go about balancing this? If you want to go by the investigation method, you will get lost along the way. But the very simple way to approach this is to use the what? The algebraic method to balance what? This kind of what? Equation. And how do we go about this? Very simple. We have been given their respective number of moles, but this time as alphabets, we need the figures, we need the numbers. How do we then go about this? Your first step, assume that the number of moles of the first compound or the first molecule or whatever it is that is given to you here, assuming that the number of moles is equal to 1. So here we are assuming that what? A is equal to 1. Just for the sake of convenience, I used A, B, C, D, E, F, G to represent all their what? Their number of moles. Now you are going to assume that what? A is equal to 1. Don't forget, for this equation to be balanced, we are simply looking for A, the value of A, value of B, value of C, value of D, value of E, value of F, and the value of G. We need to know what they are. So I put that there. As soon as we get, whenever we get their values, we just input them there so that we know what we are looking for. Now, I told you the first step is to assume that what? A is equal to 1. Having known that A is equal to 1, they will begin to pick each of the elements on the reactant side one after the other, equating them to what? To their respective identity on the what? On the product side. Now, what do I mean? Let's pick the first element here, K, potassium. K on the reactant side here, you should know that what? I don't have 4 moles of K here. Neither do I have A moles of K. I have what? 4 A moles of K. If I have 2H2, I don't have 2 moles of H here. Neither do I have these 2 moles of H. I have what? 4 moles. We have to multiply this subscript by the what? By the coefficient. I believe you get that. So here I have what? 4A on the reactant side here. There are what? There are 4 A moles of what? Of K. Now, do I have K on the reactant side again? No. If I'm crossing this arrow, which means I'm introducing an equality sign. So for K, I have 4 A moles here. Now, for K to be balanced, it has to be equal to what? How many moles of K do I have on the product side? 2D, which means that what? K must be equal to what? 2D. That is for K. I do not have K anywhere else on the what? On the product side. Let's pick the next element, Fe, iron. If I want to balance iron, on the reactant side here, I have what? A moles of iron. Do I have iron on the reactant side again? No. I'm also crossing the what? The arrow this time around. So I introduce my equality sign. Where do I have Fe on the product side? Here. Which means for this equation to be what? To be balanced, A must be equal to what? E. Sweet. Next element, carbon, C. For this equation to be balanced, how many moles of carbon do I have here? Don't forget that this 6 here is for what? Carbon and nitrogen. I have what? 6A of what? Of carbon. Do I have carbon again? No. Which means to the what? The product side. Then I introduce my equality sign. Where do I have carbon? CO. So which means what? For this equation to be balanced, number of moles of CO here is G. Which means what? 6A must be equal to what? G. Let's call this equation 1, equation 2, and let's call this equation 3. As we continue, nitrogen, N. How many moles of N do I have here? I have what? 6A. Yes. Then where do I have nitrogen again? N. On the product side. So I introduce what? Equality sign. Then my N here is what? 2F. I think that's correct. My N is equal to what? 2F. Let's call this what? Equation 4. Who again do I have? I go to the next compound. I pick what? Hydrogen. Hydrogen. How many hydrogen do I have on the what? On the reactant side here? I have 2B of hydrogen. Where do I have hydrogen again? Here. I also have what? 2C. That's all for the reactant side. Then I bring my equality sign. I go to the product side. Where do I have hydrogen? Here. I have hydrogen here. And how many hydrogen do I have here? I have what? 8F. Yeah, that's 2 multiplied by 4. That's what? 8. So that's what? 8F. So let's call this equation 5. I'll continue on this side. So which other element are sulfur? Sulfur. How many sulfur do I have on the reactant side here? I have 4B. I'm so sure we are following. Now on the reactant side, for sulfur, sulfur S, I have what? B moles of sulfur, B moles of sulfur, and that's all. Then is equal to what? Where do I have sulfur here again? On the what? On the product side. Is equal to what now? D. B moles of sulfur is equal to what? D. I also have sulfur here, plus E. Where do I have sulfur here again? Plus F. I believe we are following. Let's call this equation 6. What else do I need? I'm done with hydrogen, I'm done with sulfur. Okay, oxygen. Oxygen. How many oxygen do I have on the reactant side here? I have what? 4B moles of what? Of oxygen. Where else do I have oxygen? Here, water. Plus what? C. Then introduce my equality sign. Where do I have oxygen? I have oxygen here. That's what? 4D plus. I have oxygen here again. That's what? 4E plus. I have oxygen here again. Wow. That's 4F plus. And I also have oxygen here. That's G. I believe this is correct. Wow. Oxygen 4B plus what? Plus C, giving me what? 4D, yeah? Plus what? Plus 4E, plus what? Plus 4F, plus G. Now, let's call this equation 7. If you have gone through all these procedures correctly and accurately, then you are good to go. Everything becomes very easy. Now, don't forget, our first assumption, or our first step was to assume that what? A is equal to 1. So we're assuming we know the value of what? Of A. Now, let's pick it from equation 1. From equation 1, I want to bring the solutions up here. From equation 1, what's my equation 1? 4A is equal to 2D. If 4A is equal to what? 2D. Knowing fully well that what? My A is what? Is equal to 1. So which means I substitute the value of A into this equation. That becomes 4 into 1 is equal to what? 2D. So that what? My D will be equal to what? 4 over 2. And that's 2. Don't forget A is 1. D is what? 2. I believe this is cool. Then we go again from equation 2. From equation 2, What's equation 2? A is equal to E. If A is equal to E, knowing fully well that what? A is equal to 1. That means what? 1 is equal to E, so E is equal to what? 1. So I bring it here. You can see the only complex step, which is not really complex if you follow it correctly, is just to analyze all the respective number of moles of each of the elements on the reactant side and on the what? And on the product side. Simple. Having done that, everything becomes easy. Now, what's the next element or the next equation? Let's go to equation 3 to look for the value of what? Of G. So from equation 3, I have 6A. 6A is equal to what? Is equal to G. 6A is equal to G. If 6A is equal to G, knowing fully well that what? My A is equal to 1. So I bring it here again. 6 into 1 is equal to what? G. So that G will be equal to what? 6. Simple. What else again do I need? I go to the next equation. 2B plus 2C is equal to what? 8F. B is unknown. C is unknown. F is also what? Unknown. So let's jump this what? Equation for now. Let's go to the what? To the next equation. That says what? B is equal to what? D plus E plus F. If my B is equal to D plus E plus F, I think I can work with this equation. That's from equation 6. From equation 6, that says B is equal to D plus E plus F. So that my B can be equal to what now? My B can be equal to what? What's my D? My D is equal to 2 plus what's my E? My E is equal to 1. F is also unknown. Wow. Wow. Did I leave out any equation? Okay, I think I left equation 4. Sorry about that. So let's erase this and use equation 4. So from equation 4, sorry I left that out. That's a mistake on my part. From equation 4, I can get the value of F. That says 6A is equal to 2F. Yeah, knowing fully well again that my A is equal to 1. So I can say 6 into 1 is equal to 2F. That means that what? My F will be equal to what? 6 over 2. And that's what? 3. Okay, here I can now come back to use what? This equation, equation 6. Because if I want to use this, yes, F is known, but C is unknown and B is also unknown. So I have two unknowns here. So I skip this equation, I come to use what? Equation 6. Now it becomes very much convenient. So from equation 6, my equation 6, B is equal to D plus E plus F. So that my B will be equal to, what's the value of my D? 2. What's the value of my E? 1. And what's the value of my F? 3. So that this will be what? 2 plus 1, 3 plus 3, 6. Which means my B is equal to 6. A is known, B is known, C is unknown, D is known, E is known, F is known, G is known. So I just need to get the value of what? C. So in which of these equations do I have C? I have C in equation 5 and I also have C in equation what? 7. I can decide to use any of the equations. I'll still get what? Same thing. So but let's use the shorter one and then we go. Now from equation 5, let's bring it here. From equation 5, what's there in equation 5? 2B plus 2C is equal to what? 8F. Yes, 2B plus 2C is equal to 8F. What's the value of B? The value of B is 6. That's 2 into 6 plus C is unknown, so 2C is equal to what? 8F. What's the value of F? 3. That's 8 into 3. Sweet. Then 2 times 6, 12 plus 2C to give me what? 8 times 3 is what? 24. So that, I'm bringing it here. So that what? 2C can be equal to what? 24 minus 12. 2C can be equal to 12. C will be equal to what? 12 divided by 2. And that's equal to what? 6. So the value of my C is 6. A is known, B is known, C is known, D is known, E is known, F is known, G is known. We are good to go. Everything is set. I can then verify by replacing what? The values. My A is 1. There's no need to put the 1 there. Then my B is what? 6. B, 6. They look alike. That's cool. Then my C is also what? 6. My D, 2. My E, 1. My F, 3. And my G, 6. So by the time we cross-check this, you see that this equation is balanced. I have 4 moles of K here. I also have 4 moles of K here. I have what? 1 mole of what? Of Fe here. I also have what? 1 mole of Fe here. Balanced. I have what? 6 mole of carbon C here. Where do I have carbon? I have 6 mole of what? Of carbon here. Balanced. I have what? 6 mole of nitrogen here. Where do I have nitrogen? I have 2 times 3. 6 mole of what? Of nitrogen here. Balanced. Where else? Hydrogen. I have 12 plus 12. That's 24. Where do I have hydrogen? Okay. This is 3 times 2, 6. 6 times 4, 24. Balance. Sweet. Then where else? I have sulfur. 6 moles of what? Of sulfur. Where do I have sulfur in my equation? On the product side. I have sulfur here, 2 here, plus 1, that's 3. And plus the 3 here, that's 6. Balanced. Where else? Or what else? Oxygen. Oxygen. I have what? This is 24 plus 6. That's 30 oxygen on the reactant side. Let's confirm or let's verify. So here 2 times 4 is what? 8. 8 plus 4, that should be 12. And then 12, this is 3 times 4, 12. So 12 plus 12, 24 plus 6, 30. So I believe with this detailed explanation, hence you should be able to what? Balance chemical equations using the algebraic method. It's as simple as that. We have come to the end of this topic and of today's episode of what? Made Easy Clinic. I'll see you sometime, someday. I remain Dr. Bush, the chemistry instructor at the Peak Construct for Higher Learning. Thank you.